Example 12 says, well, what is the decay factor for the model? And round your answer to 3 decimal places. So the decay factor is B. And B from our model was 0.984. So this is the decay factor, and we know it's a decay because the number is less than 1. By what percentage does the population decline each year? So now we're looking for the rate. So the rate is related to B. B is 1 plus the rate. So if we want to solve this for R, we'll get that R is B minus 1. So if I take my 0.984 and subtract 1, I get negative 0.016. So this is a percentage in decimal form, so when I multiply by 100, I get that it is reducing by 1.6% each year. How long will it take the population to fall to 100,000? And if the flood happens on January 1st, 1870, when does the population fall to 100,000? It says give the year and month. So the first thing I need to do is I need to figure out, well, first, how long is the time in years? So this is where putting our model in Y1 is helpful for us. So if I go to Y equals, I can see the model, and I want to find when it's 100,000. So I'm going to enter 100 because the units were in thousands, so I just need 100 to represent 100,000. So then I'm going to go to my window, and I want to adjust my my X values from 0 when the flood happened to, let's go out 50 years. So then I'm going to graph. So it's done graphing and we don't see anything. So now if I go to zoom and I scroll down to zoom fit, remember it adjusts the Y values with leaving the X values intact. So now it's going to auto adjust it so we can see hopefully the line and the exponential function. So there's our decay function. And now we'll see the line of 100,000 sweep across. So where these two graphs intersect is it's going to return the value of time in years. So if I go to second calc and I scroll down to intersect, it's going to grab the first curve, the second curve, and when I hit enter, all right, it says it's about 35.878 years. So T is 35.878 years. So now it wants me to convert this to an actual year and month. So this is the same thing as saying 35 years, right, plus 0.878 of another year. So I need to know, well, how many months is this? So we can convert that by saying 0.878 years times 12 months in 1 year. So we can see years is going to cancel. And when I multiply this out, I get 10.5 months. So if time 0 is January 1st of 1870, and I add 35 years plus 10.5 months, this puts me in 1905. So the first two numbers are returning the year, right? So we're somewhere, this is going to be January 1st of 1905. Then I need to count 10 and a half months. So 10 full months gets me all the way through the end of October. Then that 0.5 means we're halfway through November. So now we can say we are in November of 1905. When is the predicted population, or what is the predicted population of the city at 10, 20, and 30 years? So if we go back to our calculator, since our X scale was 0 to 50 years, all of these numbers are where we need them to be. So all I need to do to get this very quickly is go to second calc, value, and I'm going to enter 10 years. So if you look at the top, it tells you it plugged it into Y1. If your calculator says Y2, you can scroll with the up-down arrows and it will plug it into each line, right? So if you're seeing 100, if I just scroll up, I can now see the population at 10 years, and it's right here. So when T is 10, the population is 153. And since my table only rounded to 1 decimal place, I'm going to round to 1 decimal place. So 153.2. Obviously, on your exams, they tell you exactly how many decimal places to round to. So we can do the same thing for 20 years and 30 years. So the beautiful part of this feature on your calculator is I don't have to go to second calc again. I can just type in 20 and hit enter. And now it's giving me the population is 129.9. And if I type 30 enter, the population is 110.2. So it makes sense that it hasn't reached 100,000 yet, because we saw in the previous problem that it's not going to get to 100,000 until 35 years at least. The last question says, well, what is the error for the population at 5 years and 8 years after the flood? So in order to measure this, we need to check T at 5 and T at 8. And error is the actual value minus the predicted value, and that's going to give me my error. So the actual values we just pull off the table. So at T equals 5 years, we had 168.7, and at T equals 8 years, we were at 158.1. To get the predicted values, we're going to go back to our calculator, and I'm going to type in 5, and it gives me 166.4. If I type in 8, it gives me 158.3. So 166.4, 158.3. So now I just subtract these numbers. We'll just type them into our calculator. Here the error is plus 2.3, and here the error is negative 0.2. So these are in thousands. So this first error, because it's positive, means that the model under-predicted. Here, because the error is negative, the model over-predicted the population.